SBA Higher Application Maths 2025. Let's go. SBA Higher Application Maths 2025, question 1. Estimate the number of portions of fruit and veg that a typical person eats during their childhood. Now, I've got a bit of bone contention with this question just to start with, actually. Childhood, what does that mean? That can vary by culture, what a childhood is. But in the UK, a child is defined as up to about 18, usually. So I think using that, but I think this is a Fermi estimate. So as long as your assumption is reasonable, I think we're okay. So I'm just going to assume, let's say 18 years of childhood. In fact, I might go a little bit lower than that and say 17 years. Let's say as a baby, you don't eat very much. So you've got up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, let's just assume 18 years. Why not? Let's go 18 years. I think you'll get away with anything that seems reasonable. If you're assuming that 12 years of childhood or whatever, you can never tell till the mark scheme comes out. But it's the method that's important really for this question, because it really is pretty simple after that. Assume how many portions? Well, whatever you think. Standard, I think, in my head is 5, isn't it? So 5 portions per day. And well, we're going to assume 365 days a year. We're going to skip these leap years. Yeah, that'll do. So we'll just do our sum. 18 times 5 times 365. Get a calculator. Which is 32850. But again, I must stress, your answer may be wildly different from mine, because you might have made different assumptions. The question's about, can you make reasonable assumptions and do a sum with it? It's always going to be a time sum. Clelland Maths is sponsored by Lecky, the educational publisher for Scotland. They offer viewers of this channel a massive 30% discount. Just use the discount code ClellandMaths at leckyscotland.co.uk. The practice question books go all the way from level 3 to advanced higher and include National 3, 4 and 5 apps as well, so you can get any book you need for your studies. These are an excellent resource with questions on every topic and contain work solutions so you can see how the marks are awarded. As you go through the book, the questions get increasingly difficult, so by the time you finish your book, you'll be ready for your exams. Usually £9.99, just use the discount code ClellandMaths to get 30% off that. Link down below. SBA Higher Application Maths 2025, question 2. A group of gym members were asked what machines they regularly use from a choice of treadmill, row machine and cross trainer, and you've got all these results. We have to complete the Venn diagram to show this information. So always start with the one in the middle. So the one in the middle is all 3. 4 members use all 3, so 4 goes in the middle. And then we can start working on our double choices. So 38 members use treadmill and rowing machine. So treadmill and rowing machine has to add up to 38, but I've already got 4, so I've got 34 left over. 32 use cross trainer and treadmill. So again, cross trainer and treadmill has to add up to 32, but I've already got 4, so that leaves 28 left over. And then 15 use rowing machine and cross trainer. At the bottom, the intersection of that is 15, but take away 4, so I get 11 in this box. So there's my boxes filled in for that. Then we go on to our single boxes. 90 members use the treadmill, 90 in total though, so I need to take away, it's not 90 only use the treadmill. So 90 minus 34 minus 28 minus 4 leaves 24 left for the treadmill. 85 used the rowing machine. So again, for the rowing machine, you've already got these numbers in its circle. So it's 85 minus 34 minus 4 minus 11, leaving 36. And then finally, 53 use the cross trainer. So it's 53 minus all of these numbers, 28, 4 and 11, which gives me 10. A number that sometimes people forget to do is, well, none. 13 use none. We can either get that from the question, or if it gives us a total, we can take away all the numbers to get it. Complete the Venn diagram. We're done there. A gym member is selected at random. Determine the probability that they regularly use the rowing machine and the cross trainer, but not the treadmill. So rowing machine and cross trainer, there's the cross trainer, there's the rowing machine, there's the intersection between them, So it's 11. Use both, not before, because that's for treadmill as well. You have to use the rowing machine and the cross trainer, so it's 11. So 11 is my top number. And my bottom number is 24 plus 28 plus 10 plus 11 plus 36 plus 34. So if you've went around the way I've just done, you've done all of these ones here, and you've missed the 4 in the middle. I mean, you've also missed, of course, the one on the outside. 160. 11 out of 160. It's a fraction. You could change it to a decimal if you want, which is not very great. Percentage would be better, so times by 100. About 6.88%. But I'm happy that the fraction would be fine as your answer. SBA Higher Application Maths 2025 question 3. You need to refer to deductions from salaries. Elena earns a gross annual salary of 24,960, pays 8.2% of her gross annual into her pension, and pays 82.56 national insurance per month. What is her net monthly salary? Okay, so for this question, we don't need to work out the national insurance. We just need to work out the tax. So you can ignore the national insurance part of the data booklet and just grab the tax bit, which is here. But don't be so hasty. With pension, you need to take that off first before you calculate tax. Not before you calculate national insurance, but before you calculate tax. So I need to work out her taxable pay. So it says 8.2%. So I could just do 100 minus 8.2 to leave 91.8%. So 24960 times 0.918 will tell you her wage once you take off the pension. Now, if you don't like that, that's completely fine. You can just do 8.2% and take it off. And in any case, you will get 22,913.28. And we'll then use that with the tax table. So there's our tax table. So personal allowance 0. For starter rate, we just do the bands, 14,876 minus 12,570 times 0.19. Which is 43814. We now move on to the basic. Always bearing in mind what their wage is. The wage, remember, is 22,913.28. Well, that's above this number here. So I use their wage minus 14,876. 22,913.28. Minus 14,876 times 0.2. To get 1607.46. Rounding up. So total tax is £438.14 plus 1607.46, which is 2045.60. So now we need the net wage for the month. So you could work out the total national insurance for the year and take everything off and divide. Or at this stage, you could just take away the tax and divide by 12 and then take away the national insurance. And I think that's the quickest way. So that's the way I'm going to do it. So I've already got our taxable pay. So I've already took off the pension. So I can just do £22,913.28 minus my total tax of that. And then divide by 12. Being as efficient as I can by using my calculator's brackets. £1,738.97. So that means that our net month pay is 1738.97, and the only thing we've not took off is the national insurance given to us in the question, which is 82.56 per month. To get a grand total of 1656.41. And we're done there. Basically, high application to maths 2025 question 4. A company makes handmade teddy bears. The tasks required to make each bear are listed below. The Gantt chart shows the task with float times when 3 employees are available, but each employer does a single task. So the tasks are in hours, and we've got all the tasks down the side. And in a minute, we're going to ask the critical path and to make a pair chart. So state the critical path first of all. Well, that's just the task with no float. A, B, H, and I, and they all go into each other. So A, B, H, and I to start with. So now to fill in one of these, which is a pair chart, we need to work out how do we read a Gantt chart to get back to a pair chart. So usually when you've got a pair chart and you're going to a Gantt chart, let's say that was task A. And then we'll just put A, B, H, and I in to start with. Well, we know that looking at A, it starts at 0, it takes 2, and because it's critical, it has to end at 2 as well. And that's what that shows. It starts at 0, it takes 2, and it ends at the end of day 2. If we look at B, it starts at 2, it takes 6, and it ends day 8. 2, 6, 8 then. Let's do the same for H. 8, 1, 9. And similarly for I, 9, 10, 9, 1, 10. Now I've put this in the middle. It doesn't matter whether it goes there or whether that and that become A, B, H, and I. You'll get the same answer. So now we move on to the other tasks. So looking at the other ones, we have to have a continuous path. So we can actually look at our tasks as well. Cut materials, sew clothes, embroider t-shirts seem to go together. Cut accessories and sew accessories seem to go together. And does that agree? Well, if I look at C, we've got C, have some float time, but that's fine. D, E, but then the float time, because A and B lead into that already, so we need it to end there. So that's right, C, D, E, H, I. So we can put C, D, E, H, I. And similarly for the other ones then, F and G, well, F goes into G, and then G has to wait till B finishes, then H, I. So F, G, H, I makes sense for the other ones. So then we'll just put in our earliest, our duration, and our latest end time. So let's start off with the bottom, C, D, and E. 0, 2, 4. D, 2, 2, and then 6. E, 4, 2, 8. And then moving at F and G. F starts at 0. It should take 1, but we can go all the way to the end of day 6. 0, 1, 6. And G starts 1, takes 2, but we can go all the way to day 8. So 1, 2, and 8. And there that should be a completed pair chart. We can check if that makes sense. So let's have a look at doing it the way we normally do it. 0 plus 2 is 2, 2 plus 6 is 8, 8 plus 1 is 9, 9 plus 1 is 10, 0 plus 1 is 1, 1 plus 2 is 3, but it's the longest we need, so 8's fine. 0 plus 2 is 2, 2 plus 2 is 4, 4 plus 2, but it's the longest we need, so it's 8. Going backwards, 10 minus 1 is 9, 9 minus 1 is 8, 9 minus 1 is 8. So 8, 8, 8. 8 minus 2 is 6. 6 minus 2 is 4. 8 minus 6 is 2. 8 minus 2 is 6. So it appears to be right. Question C. Determine the minimum time taken to make each teddy bear when only 2 employees are available. Now remember, these tasks have to come after these tasks. So you can't just randomly go in and do tasks. But what you can do is having simultaneous work. So let's say we had, let's call that employee 1 and employee 2. Employee 1 does A, while employee 2 does C. Then employee 1 could move on to B, or they could move on to F or G. So let's say they just move on to B. Well, that means that employee 2 can do D. Now, while we're doing that, that's 2. So we could do something else that takes 2. Well, that's E. And then what's left is F and G to be done. Well, employee 1 is still working on B. So there's no choice but for employee 2 to jump to F now. Now, employee 2 jumps to F. So they're doing C, D, F. That's 2, 4, 5. An extra hour there, and then they do G. So that means that when this person's finished doing A and B, we need to wait an hour until G is finished. And then it doesn't matter who does H. Somebody does H, then somebody does I, but they come after each other. So that's kind of your idea here. So if you look at your durations, A and B become, that's 8 hours. But C, D, E, and F is 2, 4, 6, 8, 9 hours. And then you've got 1 and 1 for each of them. 9, 10, 11. So it's 11 hours. It doesn't matter how you divide that up, it's always going to be 11 hours for 2 employees. S2A, Higher Application Maths, 2025, question 5. A radio station asks our listeners to report how many hours they are listening for in a week in July. And we have to do a histogram using statistical software, describe the distribution, and generate appropriate location measures of location to summarize the data. And then the data was used to determine listening hours in last summer. Explain why, one reason why it misrepresents this, or could misrepresent it. Let's jump into RStudio. So I've got RStudio loaded here. The first thing we need to do is file, new file, RScript, which I've already done, and then session, set working directory, choose directory, which I've already done. I'm on the cloud version of this, so the only difference is this little bit here looks slightly different, but nothing else. So let's get this in. So we go to our data booklet. My data is the first command. So we get that in there, and we read here, we change that to Q5 radio. Control Enter. And now we need to attach my data. And then we need a histogram. So data booklet again. Histogram is here. X is whatever the data is called on the x-axis, which is hours, is what the variable is. So we call X hours. Main appropriate title. Histogram of, let's say, radio listening hours. Could say in 1 week in July if you wanted to, but you could just say that and we can see what we get. X-axis label, well, the x-axis label is the number of hours listening. And the y-axis label could be number of listeners, or frequency is probably fine, so I'll just leave it as frequency. And we get a nice little histogram here. Histogram of radio listening hours for 1 week in July. Probably don't need that bit, but I'll put it in anyway. Frequency up the side, or number of listeners. Number of hours listening on the bottom. I will change it to number of hours listening per week, just to be very clear on the bottom. But I don't think you'll really need it. But there we are. We've got that there. Now we need to put that into our output. So right click, copy image. We've got our Word file and paste picture, and it'll be far too big. Don't know why. We can just make that smaller by dragging in that corner and getting it in to an appropriate place. I think that'll do there. That's a good little picture. Histogram of radio listening hours 1 week in July. Frequency, number of hours per week. Question 2. Well, what was question 2? You probably can't remember. So let's go back and see. Describe the distribution of data shown in the histogram. So you should be able to see here we've got the histogram, and if it went up like this and then back down nicely, we would say that it was normally distributed. But in this case, there's a tail to the right, especially with these outlier here probably. So I would say that it's positively skewed. If there's a tail to the right, it's positively skewed. If there's a tail to the left, so it was high here and going like that, it'd be negatively skewed. So positively skewed, I think I'm going to put. So positively skewed. Pretty happy with that. Right, part 3. Hens generate and state the appropriate measure of location. So, location we're looking for. So let's look at the data booklet. Descriptive statistics is what you're looking for when it's a measure of location and spread. Now, if it was normally distributed, you would do the mean. And that's the location, and the spread would be standard deviation. However, if it's skewed at all, then interquarter range gives you the spread, and median tells you the location. So we're looking for the median. Now, we're just going to use the data booklet. So the data booklet doesn't have anything in here for median except doing a summary. So we'll just do a summary. Although you could probably guess that if you type in median, it would probably work. Summary X was hours. And it gives us a summary. So there's a statistical software output. And we'll copy that whole thing in, but then we'll state the correct one. So there's everything. But our answer is median, which equals 18.7 or 70 hours. Now we're done there. State one reason why the data might misrepresent the listening hours last summer. You could do this question without even seeing the data. It tells you right at the start of the question, actually. A radio station asks for listeners to report how many hours they are listening for 1 week in July. And this question asks you, why does it might it misrepresent listening hours last summer? Well, last summer is not the whole week of 1 week in July. It's probably about 8 weeks. So it only represents 1 week. It doesn't represent the whole summer. That's it. The data was collected only for 1 week in summer and not the whole summer. Listening habits might vary across the summer. Something like that. You could mention that it might vary because stuff could happen. There might be major events, there might be a concert, there might be football matches, anything you want. But I think that's enough to get our mark there, so I'm going to stop there. Print the word processing file Q5 radio answers. So how to print, just in case. File, print, then print it. Nothing there. That's it. And that's that question done. Higher Applications of Maths 2025 question 6. You must refer to information on Lifetime ISA given the pre-release. Morgan owns a Lifetime ISA with a borrowing bank. The online account has an effective rate of interest of 3.25%. Morgan makes a deposit of $2,500 into her account on the 1st of January 24. So I'm setting up a timeline, $2,500. The government bonus is paid into her account on the first day of the following month, on the 1st of the 2nd, 24. She makes no further deposits in 24. Calculate the accumulated value of Morgan's lifetime ISA on the 31st of January 24, which is the same as the 1st of January 25, essentially. So we need to work out what this bonus is. So Lifetime ISA pre-release material says you can save up to £4,000 a year as a lump sum or put in cash in when you can. The government will add a 25% bonus to your savings up to a maximum of £1,000. The bonus is paid every month on new deposits that have been made. So the bonus is paid on the deposit. So we made a deposit of £2,500. So our bonus on that deposit is 25% of £2,500. So 0.25 times 2,500 is 625. So I can just I'm putting in 625 there. So now I just need to work out my interest. 3.25%. So 1.0325, add 100, divide by 100, and I want it for 1 month for that time period, but that's out of a year. So it's out of 12 months, and I want 1 month. And this one's still 1.0325, but is now 11 months out of 12 months. So my sum, that was 625, remember, is just going to be 2,500 times 1.0325 to the power over 12. But then I need to add the 625. That's step 1. 2,500 times 1.0325 to the power of 1 over 12 plus the 625 is 3131.67. So then I start again from 3131.67 times 1.0325 to the power of 11 twelfths. 3131.67 times 1.0325 to the power of 11 over 12 is £3224.84. And we're done there. SQA High Application Maths 2025 question 7. An events management company has been awarded a contract to construct stages for a music festival. If construction on stages is delayed, the contract says a penalty will be paid of £25,000. Two things that can happen: stage structure fails or staff fail to attend site. The probability of no delay is 0.76. Calculate the expected cost of a delay. So the probability of no delay is 0.76. So that means that the probability of a delay then is the opposite. No delay or delay, only one can happen, is 1 minus 0.76, which is 0.24. So there's a probability. So that means our expected cost is simply 0.24 times the penalty of 25,000. Calculator. £6,000. Number 7 continued. The company is considering the following control measures. We can pay another company to have staff on standby and it costs £1,000, or we can have a spare stage on standby at the cost of £1,500. The probability of staff failing to attend is 0.2. The probability of a stage structure failing is 0.05. Calculate the expected cost of control measure 2. So for part B, control measure 2, have a spare stage on standby, and that costs £1,500. But then we need to add on, still somebody could fall ill. So we've still got 0.2 times £25,000. So we can work it out in a calculator. 1,500 plus 0.2 times 25,000 is £6,500. And then the expected cost of control measure 1 is taken as £22.50. They must have worked it out for us. The company will only use one control measure. Explain which one they will use to minimise expected costs. Let's just check that that's £22.50 for the sake of it. So if it's £22.50, that's because the structure could still fail at £25,000. And then we're adding on £1,000 for the cost of control measure 1, which is £22.50. So that's where we got that number from. But we know if you do nothing, it's £6,000. If you do control measure 2, it's £6,500. So we should do control measure 1. As £22.50 is less than £6,000 and £6,500. So control measure 1 gives the least expected costs. And we're done there. SQA Higher Application Maths 2025, question 8. You must refer to spreadsheet file Q8, Finance, when answering the question. Martin is buying a car for £7,500. The garage offered Martin the finance package below: 20% deposit, 35 level monthly payments of £216.77, final monthly payment of £216.13, We have to open the worksheet and complete the loan schedule to work out the annual interest rate. That's a goal seek then. And then we've got a part B of this question. Okay, so in the Word document here, so in our Excel document here, initial loan amount. So the cost of the car is $2,500. If you remember back in the question, it said there was a deposit, and the deposit was, reading the question myself, 20%. So that means that 80% is left. So we could work that out by saying 0.8 times this. And that gives me my loan amount. Or you could have just worked it out manually and typed it in. No big deal. So take it off 20%. Annual effective rate of interest. Well, it told us to work that out. So who knows? So I'm just going to guess one. 30% is my go-to guess for percentages. So I type 30. And now I need the monthly effective rate of interest from that. So that is the standard command equals 1 plus our interest rate to the power of 1 over 12. And then you need to remember to take away the 1. And that will generate the monthly interest rate. Loan period is 36 months. It tells us the repayment and the final payment, so I need to copy that in. So then we have to fill in our table. So this one just equals this one with dollars, which you can press F4 for quickness. Interest content of repayment. Well, that equals, we're going to round to 2 decimal places at this point. So put that in. So we need to do the loan outstanding. Now that's not dollar because we're inside the table, times the monthly interest. That is dollar because that's outside my table, comma 2. Now it doesn't matter whether you put interest first, then F17. The order doesn't matter for times. We get an answer. Capital content, well, I've already rounded, so I don't need to do it again. So this just equals our repayment minus our interest. So this is exactly the same as doing a loan schedule that we've done loads of times. And then loan outstanding equals, well, loan outstanding minus the capital. Press enter. And then we can just copy down. So, drag my little box. And just remember that final payment we need to change. So that's okay. We can just change that here by looking up to see what box we're on. Final repayment is in C13, I think. So I'll just edit that to a 13, and it'll change that there, which means it'll change that there. So now, obviously, what we're expecting is you take a loan out, at the end it should be paid, and it isn't. So we need to go seek our interest, because obviously the interest is wrong. So we press the box, we go to data, what if analysis, goal seek, set cell F53 to value 0 by changing. So we go up, and it's the initial interest that we guessed, the 30% one. Press OK, that will do its thing. Press OK. You should get 0 in here, and we've got a 0, so we're good to go. So our interest rate has been calculated as 19.5. Now you might be thinking to yourself, do I need to edit this? Because usually I've been told I need to take that back down to the correct decimal places. No, that's for money. If you edit this now, what's going to happen is you'll no longer get a 0 here. So the answer is 19.50022009305, and that's what the bank will use to calculate your payments. But we'll just quote it to you as 19.5%. That's it. So it's 19.5%. I'm going to type that in there, but obviously we're going to print this out in a minute, so we'll just print it out. Car insurance is a legal requirement for cars driven in UK roads. Explain the purpose of car insurance for 1 mark briefly. Essentially what car insurance does, it gives you protection financially to road users. Provides financial protection, I'll say, and you could be more or less. Not just for car users, for road users in general. So to write a bit more about that, just in case the SQA are really wanting it to be expanded upon, or what is only worth 1 mark. In an accident, insurance will pay for damages, say to car/injury, even if you can't pay. You'll also get accidental damage cover. You'll get cover for fire, theft, vandalism, and obviously peace of mind. But the legal requirement really is that in the event of something happening like an accident, the insurance will pay for damages to your car or the other person's car, depending on who's at fault, and therefore it doesn't really matter if you can afford to or not, because cars are very expensive things. The insurance will cover it, and there we are. 8 continued. Martin has been saving for a deposit in car insurance, and he opened a savings account with an initial deposit of £500 on the 1st of August 2023. He made regular monthly savings of £250 into the account on the first day of each month from the 1st of September 2023. The effective rates of interest are as follows. August to November in 2023, the end of, is 0.24% per month, and for the 1st of December, 3.1%. With the open savings worksheet, calculate the balance in Martin's savings account immediately before he makes his payment on the 1st of August 24. Okay, let's do that. Already got some stuff filled in for us. His initial deposit is £500, which it says in the question, 0.24% per month. It's got the annual there, and it's actually hinting us that we need to work out the monthly ourselves. And then it's got the regular monthly payment of £250 and the balance immediately before the 1st of August 2024. And I think that's everything off of the question, so I no longer need the question in front of me. So we're going to work out this. So it's equals 1 plus the percent to the power of 1 over 12 minus 1. And that gives us our monthly percentage rate. Now we'll start working on our table. So we've got 1st of August 2023 has already been filled out. Account balance before payment. Then I made a payment. Balance after payment. So I need to work out what to put in here. So he's put some money in August and it's £500. At the start of September then, a month later, his balance is going to be 500 plus the interest he gets that month, which is 0.24. So I need to have that in there. So round. And how do I add on interest? Well, I'll just put a 1 on it. So 1 plus this times the previous balance to 2 decimal places. And now make sure you dollar the correct amount. C9's outside the table, so F4 that, and press enter. 501.20. The payment is equal to always 250, and that's always dollared. So his balance immediately after the payment is simply this box plus this box. And then we can drag that down, but not too far. It only goes to the 30th of November. So there's October. Just double checking in your head that that's working. He gets a payment in October, and then he gets the interest for October, starting November. He gets his payment up to there, and then gets his interest for November to the start of December. So that needs to be copied down one more time. There's our payment, our balance. That's for the interest in October. So here will be for the interest in November. You still get it in November at that rate. So yeah, we need another month. And then once we hit January, January will be December's interest. So we need to change the interest rate. So what you can do is just copy these boxes down again, just one time, but make sure you remember to change that one. So it's now no longer C9, it is now C12. So I can just change that number to 12. And there we are. Now we can copy down to here. And it says account balance before payment is made on the 1st of August. So that's your balance after payment here. Account balance before payment is there. So it's that number I need. So these two don't really need to be filled in. This is the number I need. So it's equals that number 3307.36. That's the balance before payment's made on the 1st of August 2024, because then he makes his payment and then his balance after payment. 3307.36. Print the car finance worksheet in value view and formula view, and the savings account in value view and formula view. So just a reminder on how to do that. File, print obviously for normal, this is normal view, but if you want to see your formulas, you go to formulas and show formulas, and that's called formula view, and it starts to give you all your formulas as you go, and then you print that as well. You do the same for both sheets. Value view, show formulas, formula view, and we're done there. SQA High Application of Maths 2025 question 9. You must refer to information on feed and checks. To monitor the effect of a type of feed on a mass, a group of chicks were randomly allocated 2 groups at birth. One group was given A, and the second group was given type B. The comparative box plot summarises the mass of chicks in grams when weighed at 3 weeks old. Explain which type of feed results in chicks with the least variability in mass. Least variability in mass, well, there is an outlier for A, but taking that out, the box and whiskers was much shorter than for A than B, so less variable, less range. And looking at the actual box itself, the interquartile range is smaller for A than it is for B, because you get the interquartile range by taking away the width of the box. Basically, it's the width of the box, taking away the lower quartile and upper quartile from each other. So I would probably just say type A, because the box plot shows a smaller interquartile range. By box A, B being noticeably taller than box A. We could also mention that the range is bigger as well if you wanted to. The range of B is a lot bigger than the range of A. So you could say that if you want. Looking at the range, B is larger than A, showed by the difference in the whiskers. You could also mention this outlier here, or you could say no the outlier, but to be honest with you, it's only worth 1 mark. I think that will be enough. Box plot A shows a smaller interquartile range, showed by box B being noticeably taller than A. I think that's enough. So question 9, part B, a hypothesis test is being performed to compare the 2 groups. State the hypothesis test performed. Well, you're going to be comparing the 2 groups, comparing the means, comparing the average weight, so it's a t-test. Okay, state the null and alternative hypothesis. Null, there is no significant difference in the mean weight of chicks, mean mass of chicks at 3 weeks old between those given food type A and food type B. And then the alternative hypothesis is just the opposite statement of that. There is a statistically significant, or just significant, will be fine, difference in the mean, because we're doing a t-test, mass of chicks at 3 weeks old between those given food type A against food type B. P-value was 0.003147. Interpret the p-value in the result of the hypothesis test in context. So we've got p-value of 0.003147 is less than 0.05. So we can reject the null hypothesis. And say, therefore, there is a statistically significant difference in the mean mass of chicks at 3 weeks old between those given feed A against feed B. So you could mention a 95% confidence interval for the true population, but I don't think you need it for this question. I think that is enough. It's just really wanting you to say, what does it mean to reject the null hypothesis for this question? The type of feed used for one group of chicks is sold in 4.5 kilogram bags. The nutritional content is shown. Explain whether this nutritional information is more likely to be for type A or type B. So if we go back up here, the mean or median mass of chicks here is just over 150, whereas for type B, it's about 250. If we look at our data booklet, it says specially formatted data will help them grow at an early stage of life required. Specialist chicks foods recommend up to age 6 weeks old. This type of feed has between 20 and 24% protein boost to enable them to mass appropriately and feather out rapidly. At 3 weeks old, chicks typically weigh 200 grams. If they've not been fed a specialist chick feed, they're likely to experience stunted growth indicated by a mass of under 200 grams. At 6 weeks old, the chicks slowly transition to another type of feed. So between 20 and 24% protein allows them to increase their mass. So let's check the protein content of this feed. Well, we've got 720 out of 720 plus 150 plus 320 plus 3310 is 4,500. And to change that to a percent, we would times by 100 once we've divided. So that's what I'm going to do. 720 divided by 4,500 times 100 is 16% protein. So if it's got 16% protein, that means it has got less than the 20 to 24%, so it's probably stunted growth. So if we look at our graphs, the median mass is under 200 for type A and about over 200 for type B, so it's likely. So we could say type A as this is below the recommended protein content of 20 to 24%. Data booklet says if less than 20 to 24%, likely to have stunted growth. Graph A shows median mass of less than 200 grams. Data booklet says less than 200 grams at 3 weeks is stunted growth. Where B has median mass around 250 grams, which is much higher than the minimum of 200 grams. Obviously, I've over-egged this and said probably a lot more than you have to say, but essentially that's it. Type A is it's below the recommended protein content of 20 to 24%, and this causes stunted growth according to the data booklet, and graph A is showing stunted growth because the median mass of chicks is less than 200 grams, which is what the data booklet says would be stunted growth. And we're done there. QA Higher Application Maths 2025, question 10. A cylindrical container has been filled with water. Initially, the depth of water is 4. The depth of water in the container increases at a constant rate of 3 centimeters per minute. It takes 8 minutes to finish filling the container. Draw a graph to model this. Well, it's just going to be a linear model because the depth's just staying the same over time. So if we watch this, initially the depth is at 4 centimeters. Initially, the depth is up the side and time is along the bottom. So at time equal to 0, I am marking off 4. So that's just right there. It then says the depth of water in the container increases at a rate of 3 centimeters per minute. So every 3 centimeters, every minute we go up 3 centimeters. So if I go along 1 minute, I need to go up 3 centimeters from 4, so that's 7. So 6, 1, 2, 3, 4, 5 in the middle there. And I'll keep doing that. But then it takes 8 minutes to finish filling the container. So we need to do that for 8 minutes. But you can kind of work out straight away that 8 times 3 centimeters per minute means it will go up to 24, but it's 24 plus the 4 we started with, so we need to end at 28 centimeters. So you can just do that and say 8 minutes later, making sure I'm on the right line, and go up to 28 and see where that joins up. So that lines up, and then just join up the dot from the start to the end, and you've modelled your relationship. You could check that you've done it right by checking your points. It goes along 1, and every time it goes along 1, it goes up 3. So there we are. Get the idea. On an iPad, it's difficult to get that exact. State the type of relationship modelled in your graph. Well, it's a linear relationship because you've got a straight line. State the dependent variable. Dependent variable, well, the depth of water is dependent on time. As time changes, the depth of water changes. So the y-axis is always a dependent variable. So the depth of water. In centimeters, obviously. Question 10, continued. Another container shown below. The container is filled with water at a constant rate of 5 cubic centimeters per second. 3 graphs are shown below, showing how the depth of water in the container changes over time. Explain which graph could model the depth of water in the container. So we've got graph A, B, and C. Well, what's happening? If I put water in, it's going to be fast at the start and get slower as we go up. So we want something that gets fast at the start and gets slow as we go up. Well, that doesn't happen at B, that's just the same over time, so it's not B. A and C, we've got a choice of now. Well, that's actually getting faster as it goes. That's getting slower as it goes. It starts fast and gets slow as it goes, so it's graph C. So how could we say that? Well, we could say that narrow at bottom means depth changes fast at start and slower as container fills. C shows fast rate at start, tapering off or getting slower towards the end. And we're done there. Basically, High Application Maths 2025, question 11. Freda has a credit card with an annual effective rate of 29.9%, interest applied at the end of each month. Payments must be made on the first day of each month. The minimum payment is 5% or £5, whatever's higher. After Freda makes his payment on the 1st of March, his balance was 823.19. He doesn't use his credit card during March. Calculate his balance on the 1st of April, after he's made his minimum payment. So we've got 823.19 times 29.9%, so 1.299. 1/12 is applied to that because it's for 1 month. So then the interest gets added on, yeah? So we can work out that to start with. That gives me 841.33. But it then says in the question that he makes his minimum payment. So his minimum payment is either 5% or £5. So I need to do 5% of 841.33 to check if that's bigger than £5 or not. That is 42.07. So that's his payment then. Take that away to get the balance. £841.33 minus 42.07 is 79926. And obviously I've picked 42.07 because it's way bigger than 5%, and we're done there. The reason why Freddie should consider paying his full balance on his credit card each month. Well, technically with a credit card, although not according to this question, if you pay your full balance each month, you would pay no interest. But I think for this question, I'll say less interest. So he should consider paying his full balance on his credit card each month because over time, Freddie will pay much less interest than by just paying the minimum balance, minimum payment. Now, I think you could say more than that. You could say something like it would take a lot longer to pay off, it will be more expensive in the long run, and there's probably lots of other examples which are reasonable, but it's only worth 1 mark, so I think that's a reasonable answer. So we're done there. Basically, high application maths 2025, question 12. You must refer to the spreadsheet Q12I colour when answering this question. Complete parts A, B, and C using the spreadsheet file. A random sample of 50 children were invited to take part in a general health study and answer the following questions. State your sex, male, female, prefer not to say. State your eye colour, which is blue, brown, and green. And are you colourblind? Yes or no? The responses from the survey were partially entered into the participant responses table. Participants 3, 7, 13, 18 responded yes to being colourblind. Participant 42 had withdrawn their consent for the responses to be included. Open the eye colour worksheet. We have to complete the participant responses table using the information. Complete the eye colour summary table. Create an appropriate chart to display the frequencies of eye colour in the summary data. So let's have a look at this. So participant 3 was colourblind. I'll just write yes. Participants 7 and 13 were colourblind. So I'll just copy that. 7 and 13 and 18. They're all colourblind. All other participants were not colourblind. So no. Now, be as fast or as slow as you want here. I'm just going to copy into all the spaces by highlighting them. Every time I see a gap, I'm just going to skip it and start again. Control V and Control C I'm using here. So Control C copies and Control V pastes. And we get it all in pretty quick then, instead of just typing it, because that would be really inefficient. You could also use YN if you prefer, or any other thing that you know would mean yes and no. What else does it tell us in the question? Participant 42 withdrew their consent to have the responses included in the data. So 42 is out. Delete. Goodbye. That's the only information we've actually got. So that's part A done. Part B, complete the eye colour summary table. So frequency means how many. And we want to know how many people have blue eyes, brown eyes, and green eyes. Now, I've had a lot of mentions about this question already, and a lot of people say, does that the count if thing? Do we use that? And you can. I mean, if you know how to do that, you should have hopefully had some training during the course on various Excel functions, basic ones. It's unclear at this stage whether or not you're getting a mark for using a formula here, because it does just say complete the iColor summary table. It doesn't say you need to use a formula. So I think there is a chance that if you were to just count them blindly and shove in the number, you might get the mark. Although I don't think they want you to do that. I think they want you to use a function. I'm going to use a function. So we'll not know until the actual mark scheme comes out whether or not we're getting a mark for the function or not, because the question doesn't tell you either way that you need to use a function. So, but I will use a function. So how do we use the countIf function? Well, we just type in here equals countIf. Open a bracket. We want a range of data, so we highlight our data, or type it in manually if you feel you must. And then our criteria, now you can't just type in blue here, you need it in inverted commas, blue, because it's a word. Close your bracket, press enter, and you get 11. Let's just check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we've got 11 there. Same command again, countIf, same range. And now the word is brown, green, same command again, same range. And now the word is green. And that's it. We've got 11, 34, and 4. Looking back at part B, A, 42 had withdrawn their consent for responses to be included in the data. We could have done something with that, as in like highlighted it, put boxes around it to say don't include it. But I think if someone's saying you've not to include my data, it really is a case of saying, well, that's fine, it's deleted, it's not part of our table at all. So I think I'm quite happy that that's what they want you to do, but rather than just mess around with it. Create an appropriate chart to display the frequencies in the iColor summary data. So for this bit, just this little table here, insert a little chart, probably a pie chart or a bar chart would be fine. Either one, anything that is reasonable. We've got an option of like a pie chart, a bar graph. When I click this, by the way, you don't see it on screen what it's shown me until I click one and choose one, okay? But I'm going to choose a pie chart because that seems best to me. But you could have done a bar graph. Now, there's that. Now, that's not good enough. If I just have that, I don't think I'll get the full mark. I need to have a better word here, a better title. Pie chart of children's eye colour. There's my chart, and then data labels. You could put them in if you want, and it would tell you 11, 34, and 4, which is quite nice. You know, it's hard to say exactly what we would want, a legend for sure, but that's good. I'll show you what you would get if you were to actually pick a different chart as well. Let's pick a bar chart this time, down a little bit. So if we'd done a bar chart instead, you would get something like that. Again, you want your data labels in. So add axis titles, bar chart of children's eye colour, say. Axis title, eye colour, axis title, frequency or number. Frequency I'm quite happy with. You could even mess about changing these colours of the bars or anything else you wanted to do, but I think that's a reasonable chart as well. So we've got a couple of nice little charts, and we're done there. Print the iColor worksheet in Formula View and Value View. So the chart is visible on one page. So as usual, file print, and if you want Formula View, formulas, and then we go to show formulas, and you get it, and then you go to file and print. And we're done there. This has been Mr. Clelland from Clelland Maths, and we've done S3 Higher Applications of Maths 2025. Hopefully you found that useful. Hopefully you enjoyed this paper. I found it all not too bad. Take care, stay safe, and goodbye.